everybody. I'm just gonna quickly present the area that I choose to demonstrate the computational toolkit. The area that I choose is Port Adelaide, which is a very important area here in Adelaide because it's the historic center of the city and it's a portuary area that had been passed through some redevelopments recently. And I think that's a good opportunity to test the computational toolkit in this area, since it has a good scale to explore some data gathering methods and some analysis. It's going to be very interesting to test here in this area. It is also important to say that this demonstration will focus on presenting the different computational tools that were developed and not in proposing a new design for the area, neither trying to do some profound and deeper analysis of the area. With that said, let's have a look on the computational toolkit. You can find the computational toolkit that was developed in the GitHub. You can put in your browser GitHub, Victor, Calixto, Mega-Polis. And this is public available under the GPL license. The computational toolkit was developed for Sverchok, which is a visual programming tool similar to Grasshopper for Rhino, but in that case is for Blender. Therefore, you need to first install Blender, and then after install Blender, you have to install Sverchok, and then you can install Mega-Polis. This Sverchok is pretty simple to install. You just go and Sverchok GitHub as well, download the zip file, and you can go to Mega-Polis and download the zip file. And to install a plugin on Blender, you can open Blender, go up to Preference, go to Add-ons, Install, and then you choose the plugin that you want to install. In that case, I'm going to install the Mega-Polis. I'm going to click in Mega-Polis and just click here and wait. So after that, you can click here and see our dependencies. If some dependency is missing, you can install the dependencies from here. After install all the dependencies, we can have a look on the interface. In the Blender menu, we can click here in the sub-menu to have access to the Sverchok environment. We can click in Sverchok nodes. This is gonna activate the Sverchok environment. We can use N to have access to the lateral menu, and or T to have access to the other Sverchok menu. But the most used way to have access to the Sverchok components is clicking Shift A, and with Shift A we can access the different functions, and at the bottom of the menu that just pop up, we can have access to the plugin. The plugin follows the structure of the framework, which is divided in gathering, analysis, generation, and visualization. And each division is subdivided in design, data, and supporting tools. To better show the toolkit, I'm gonna open a file that I just prepared for the demonstration, because we can understand better how the nodes integrate together, and also we can save some time. The file has just opened here, and this file is divided in three parts: the gathering tools, the analysis tools, and the visualizing tools. I just have to mention that the generation tools are integrated among these different methods, and also there's not so many different generation tools, since the Sverchok it's already a parametric modeler with already a lot of different methods to create geometry, to manipulate geometry, to generate forms. Okay, with that said, just gonna start with the OpenStreetMap downloader. I think that the first thing that when we are preparing for some project, we need to start to download the maps. And if we need to download the maps, we can, in that case, we can use the OpenStreetMap downloader that is just gonna collect the data directly from the OpenStreetMap website. And in this method for data collection, we have 4 different methods. We can download by using the address, is that the method that I'm using here. I'm downloading data for Port Adelaide. We can write the address here that you want to download. You can establish a distance, radius of data, or a radius of interaction of your data here, and we can define a folder where do you want to download this data. So I just have prepared this folder here. Okay. Okay, I'm just gonna download this data here inside demonstration, data sets, and downloads. We're gonna change that to that. And then when I do that, besides the 4 methods for downloading data, you can choose which features do you want to download from OpenStreetMap. You can download building footprints, but you can download other features. The features you can access in the OpenStreetMap website. In that case, I'm gonna download the buildings. Here. So if I click download here, they're going to start to download the data for me. So if I have just downloaded the data for me here, if I want, I can download other data. For example, I can download amenities data as well. I just change it, and then automatically they're going to download the related data here. So now you can load this data. I'm just going to expand my interface. So to load that data, we can use the read.js file. We can go to Mega-Polis, gathering, and click in read.js. It's the same. So in the read.js we need to choose a projection, and we can choose between path or URL. The read.js accepts geopackage, GeoJSON, and shapefiles. So here's just loaded a geopackage, but I'm gonna just load the JSON that we just have downloaded. So after loading, I can use a viewer draw to visualize the data. You can get the viewer draw in this viewer draw, and just gonna unhide the data. So these are the buildings for the area. So in the GIS, with the GIS component, you have access for the geometric properties, but you also have access to the features, and beside the features you also can have access to the features as a geo data frame, which is very convenient to operate the data. Here it is. So you can have access to the data into the relation of the data. And so we also can load for the same area the street network. To load the street network, we can use the component load street network. Load street network, which in that moment is just defined for the address, but the idea that we can use the different methods as well later. And in this node, we also have to define the projection, and we can choose which kind of street network do we want to download, and also the distance of interaction that you want to use. In that case, you're going to use the same 3000 as a radius. It's interesting to use this node because we can download the optimized street network in which all the lines are cleaned and already prepared to realize some topological analysis on the network, which is very convenient. Yeah, I'm just gonna load that. So we have the street network and we have all the intersections, and which are the nodes of the network and the edges of the network. So this is already prepared to use. And beside the geometric properties, we also have information about the network that we can use for the later analysis that we can do. And also you have access to the data frame with the information about the nodes. Here it is. Another feature from the gathering toolset it is the feature of reading last files. Last files is like a point cloud file. In which will another feature of the gathering tools. Another feature of the gathering tools is to read point cloud files. The specific point cloud files is last files, which came with some information on that. In that case, the information that comes with this kind of point cloud is intensity and classification. The classification data is interesting because we can use that to separate the data on the point cloud. For example, if I want to just collect the data about the tree canopies or the building roofs or other elements that are classified during the data collection of this point cloud, we can use that. So I'm just gonna activate, because I just like disactivate this node, and we can choose by choosing a path. I just prepared this data that I downloaded from a website here in Australia that's called Elvis. I'm just gonna activate that. Just one thing to mention, that if you are in the right coordinate system, the data will gonna be aligned. This is very interesting, very useful. Okay, the point cloud just loaded. Now I just need to visualize the point cloud. We can use this viewer draw as well. Okay, to visualize the colors, here, I can just choose this to get point per point, and you just get the classification colors. Each point has one ID that we can access through the classification method. It's important to say that the points need to be classified well. It depends on the collection. So another feature from the gathering tools is reading digital elevation models, or DEM files, which is a TIFF file in which it has information about the elevation in each pixel. So this is interesting and very important in landscape projects or projects that do with the topography. It's a very important feature to analyze. Yeah, I'm also just going to turn on this and to visualize that, I'm gonna use a different visualization method. I was using until now the viewer draw, but now I'm gonna use the mesh viewer, because with the mesh viewer we have a temporary mesh that's created in Sverchok. So I'm just gonna connect the vertices. and the faces. And the same. Versus and faces. So with the proper coordinate system, everything will fit well. So this is just a mesh with the topographic elevation of the site. Let's have a look in another feature of the gathering tools. So the feature that we're going to have a look now is the street imagery downloader. This street imagery downloader is interesting because sometimes we need to download some images from the street on Street Map and on Google Street Map, and in that case we're just gonna use this node to download the data. Here in this node you can define the projection as well, and you can define a folder where we want to download the images. I just prepared this folder here, so I'm just gonna delete these images because I'm gonna download again. So, and then I can define a radius of operation, define a folder, define a radius of operation, and for the images I need to define the coordinates, so the latitude and longitude. We can get this latitude and longitude in the okay. So you can define the longitude, latitude, just open the, you can collect from here, from the Google, or you can open the OpenStreetMap. And choose Port Adelaide, and you get the coordinates from here. The same coordinates. So, and you also define the number of photos that you want to download. In that case, I'm just gonna download 10 photos just to make the process faster. And now I just have prepared the folder here. I have prepared the projection in my radius, and if I press download, they're going to start to download the images. These images are being downloaded from Mapillary. While it's downloading that, I'm just going to quickly show the Mapillary. And the Mapillary is similar to Google Street View, but the difference here is that this Mapillary is all the images are crowdsourced, which means that anyone can collaborate in collecting this data, and is open source and crowdsourced data, which you can collect the street imagery. similar to a switch view. So here is just downloading the data. Just start to appear the 10 images that I just established here. You can click here to see the images. And yeah, and this data here, we can also visualize the points from where this data were collected. So the data were collected from these points. Just gonna change the color here. Increase the size. So 10 photos were collected from these areas here. All the photos have an ID that you can see from where the photos were collected. So these were the data collection design tools. We also have some methods regarding to data. Here, for example, we can download the data from specific API that we can provide a link and provide a folder from where we want to download, and then we can make a request and download the data in real time. We also can read CSV files. The output for the CSV files are lists, dictionaries, or data frames. And from the data frames, we can make some operations. For example, I can get one column from the data frame specifying the feature that I want to collect. In that case, I just download some data from the dog registration for that area. In the data I say a website. So, and from the animal column I can get the feature from the element color here, or I can get the feature of the color, and so on. We also, through the data gathering tools, we can create some series that is just actually some columns of features from a data frame, and we can create this by using the component pandas series. Is pandas series, and if you combine two or more series together, we can use the component that's called pandas data frame, and then we can create specific data frames with that methods. We define what the name of the columns. To define the name of the columns, you can use this method. This method is a generation method that's called split string. Is also from the component. The split string is in gathering data tools. And the last gathering tool for data that I'm going to show is the get sample data frame. The sample data frame just going to use some of the most notorious public available data frames that you can use to test some of the functionalities or test some models. So get sample data frame, you download these data frames for you, and here in data, get sample data frame. Here you have the Iris data frame, the California housing, diabetes, and so on. You just click wait, and this is gonna download the data frame for you. Now we can have a look on the analysis tools. So the first tool that you can have a look is the DEM attributes. This tool uses as an input the read DEM tool. It's gonna get the array of the read DEM of the digital elevation modeler, and we're just gonna turn on this. So, and what this does is just do some analysis of the topographic aspects of the terrain. We have a different methods for analysis. So, and combined with the plot then component, we can plot an image. In that case, I'm plotting the aspect of the terrain, but we also can plot some other elements. This is important on some landscapes projects. So the other tool is the white box tool. This node makes the connection with the white box toolkit. The white box toolkit is a geospatial platform used to perform different data analysis in geospatial data. So we can have a look on the site whiteboxgeo to check that later. So what this component does is just connect the white box with the Sverchok. So if you run that, this is gonna open the platform where you can perform different analysis in different formats. And LiDAR points, some analysis that we just did here from the terrain. We can do some in the GeoTIFF and so on, different types of analysis. So it's just an easy way of connecting the white box tool with the visual programming environment. So the other tool here that's part from the design is the network analysis. The network analysis will perform analysis on the network that we just download here, right? I'm just gonna hide some of these elements from the network analysis. So as I said, is that there are different network analysis that you can do. I just choose the closeness centrality and some between centrality, which is spatial analysis methods that we can use to analyze your network. I chose these methods as initial methods because from that you can use the outcomes from here to analyze, for example, social interaction, because these methods of centrality you can see how integrate the network it is. Yeah, I choose some methods of centrality because I think that is important, but yeah, other methods can be implemented later. And here what you get as an output is the values and the colors. So yeah, you can perform some analysis to see how integrated the network is. So another implemented node for analysis here is the shortest path. With the shortest path you can measure what are the shortest path from one point to another in the network. So if I got these 2 points here as example, I can choose the points here of the, I'm gonna choose one of them. Just establish what are the starting point and ending point, and then with the shortest path that you can find here under Mega-Polis analysis design tool shortest path, you can establish the method that can be shortest path by length or travel time, and then when you do that you can get what it is the shortest path between the different nodes. You can choose another node, for example. Yeah, this is gonna get from the actual lines here from the nodes. And you can then compare if the shortest path by length is different from the shortest path by time. Yeah, just a little bit different. So just some of the analysis tools or the design analysis tools. So now we can have a look on the analysis data tools. So the first node that we can have a look is the get sample data frame. This node will search from some famous data frames that are used for test. So in this node you can get these 5 data frames. I'm just gonna get one to have a look on that. So if you put this here, so yeah, you can have a look on the different data frames here. You can just search and get these data frames. So this is good to use for testing. All right. So the next node that you can have a look is the data frame utils. So this data frame utils is good for the data exploration part, or EDA, exploration data analysis. It's good when you're trying to make sense of your data. in this node, just implement the info that you can get some data about. You also can implement the head, that you get the first columns of the data frame, the tail, that will get the last column, the last rows of the data frame, and describe, that you get some important information about important statistical information about your data frame. So you can have like count, you can have the mean, you can have the standard deviation, you can have the percentage as well of the data. This can be a bit tricky to visualize. So because this can be a bit tricky to visualize, I implement a node that's called data frame visualizer. In the data frame visualizer, you can, for example, use that to visualize some sample data. For example, I can put like test data frame here, and then I can get the data frame visualizer, and I can choose where I want to put this data. For example, I want to put in test data frame, and I can dump the data here. So in here we can have a better visualization. Yeah. So yeah, the next component is a group of components. Yeah, one important task when you're dealing with data frames is the ability to create and combine different data, and combine and create this different data as a data frame. So what I have implemented here is I'm just calling some data that I got it from census, Australian census, and just reading as a CSV file. And then these components are creating some panda series that can be combined as a data frame, so column by column. So I just getting data from different CSV files here, and combine the CSV files with this, and getting some columns from the CSV files to create some series, and from this series creating a data frame. So first I create the series, and then I join this data and create a data frame. So these two components are pandas, the get features data frame. So because from the CSV file we already transform the CSV file in a data frame, and then I get some specific features here. So for example, here I get the ID of the area, here I get the information related to density, here I get the information about the average house wood size, and here about the income, and so on. So with that, with the data frame, combine it here, we can start to analyze this data. So for that I created this component that correlates the data. There are two types of correlation here implemented. One is the correlation that correlated all the features from the data frame, and the another one correlated one specific column. We can choose the methods of the correlation, and then I just create this component that I'm gonna implement later to plot the correlation. So we can plot as a heat map matrix. Yeah, I have to choose the color map and choose the boolean as well. And then you just plot a figure from the features that I want to correlate here. All right. So can also plot other, implement these to just scatter plot. Probably I will implement other methods later. So, but you can choose the method of plot that you want, and also plot this. All right. So the other matter of correlation here is the correlation width, where you can define a data frame in a series that you want to correlate that. Okay, we can correlate it, but we also can use this data to predict. To predict something, we need some to create some model. I just implemented here some linear model methods. So I have just implemented here some methods for linear to create some linear models. I'm just using the model selection just to demonstrate that, and again some features. The creation of model can be done in 4 steps. We first select the model, then we fit the data for the model, then we create our prediction, and then we evaluate the prediction, right? So I'm just getting the data from the model selection, and then I'm fitting this data, choosing a model, right? These I'm just using linear, but we have the Ransack and Rigid and ElasticNet, other linear model methods. Each one has one purpose. I'm not gonna go in deeper on that right now because we don't have a time, but yeah, you can have a look on the scikit-learn for more information, because these nodes are based on the scikit-learn. So you can feed the data and you can run the feed data. You define the train size, and from that you can predict from your model, predict how the data will behave, and then you can evaluate this data. For now we have the linear models implemented, but the idea is to implement other models later, non-linear or multivariate linear methods, etc. All right, let's have a look on the final nodes for the analysis data. Yeah, this is one of the most exciting nodes for me. There's some recent research that are trying to understand the subjective design qualities of the urban environment, and they are doing that by using deep learning and image segmentation, object detection. This is very interesting because we can start to trying to understand the subjectives concepts from the urban environment. And from this recent research, we can do that is using code, but I was wondering if you could implement that as a node in Sverchok, then make this easier for the process. So what I did is I just implemented some of these methods in which you can make some segmentation on images, or you can detect objects in using different methods. So this node is called image segmentation. What you can do, let's have a look on this node first. What you can do with that, you can segment images, or you can get some instance from the images using it, and you can do that by image, folder, or video. You can use your CPU or GPU. So let's just to quick show an example of that. I have a privilege just download some images using the mapillary download method from Port Adelaide, and then I just define here a output folder here, and I can choose a method. There are different methods here. I'm not gonna go deeper in any one right now because also we don't have time, but you have like object detection, you have instance segmentation, we have key point features, we have a panart segmentation. You have different methods of segmentation and different methods of object detection here. And if you press run, so it starts to segment the images. So yeah, from here we got the segmented image, and also you got a CSV file with the instance that was identified. In that case, that's panart segmentation. You got that with the score of the instances, and also the semantic segmentation of the elements. And from that, we also get a pixel ratio that you can use to do the research that I just mentioned before. So because these research are based on the counting elements that you can see from the pedestrian perspective. Okay, let's have a look on the object detection node right now. So this node, we can have different inputs to detect instances on an image, on a webcam, on folder, or video. So different inputs that you can use here, and this can be used, for example, to track pedestrian activity or other elements on your video or image. So in this returns as an output one CSV file with the countings. So let's just quickly test here. If I press run, okay. So this is the object detection node. Okay, now we can have a quick look on the visualization tools. Yeah, I have already shown some of the visualization tools here. For example, the plotting heat map, the plot seaborn, and yeah, I already have seen some of these tools. So what I'm gonna put some focus is gonna be on the dashboard tools. I believe that dashboards start to become some very important element on this way of presenting data in a more interactive way, in a way that you can simplify your outcomes and talk to different stakeholders. So the focus of this dashboard, you primarily trying to focus on that in a way that you can present these parametric relations and this data in a more user-friendly way. Yeah, the idea here is that you can run on the fly dashboard that you can interactive change and 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 besides that you can share with the different stakeholders because this is going to create an app that you can put in a server and share that with other stakeholders. So either just prepare this that you can have the different components. For example, you have the dashboard markdown where you can write some text. For example, here write like some title, Port Adelaide study, this dashboard presents, and so you can write in markdown and you can load here, and you can load maps. You can load the JSON. You can load the. So I just load different maps and plots. It's better if you have a look on the actual dashboard, and then we can have like a better understand what I'm talking about. So here just a way of they can interactively design your dashboard, and then you can create the dashboard. You just choose a place where you can save it, and then you can just call the server to run the dashboard. You're just gonna run the dashboard. So the interesting thing of this dashboard that you can interact with these maps. For example, I can change the color or use an attribute on the color. For example, I can change this. This layer doesn't have many attributes, but I can change here, for example, one field or name, for example, and you can put a legend. So you can interact with have a map. Same here with this JSON that I just prepared. I'm just loading that directly from the Sverchok. So we can choose a field here. For example, I can change this one for the names and use the legend, or I can choose another field. Like ASA2 name, and then I have like a more. So if we have like the data on your JSON, you can interactively change here. So I just run some data from there. It's just testing some plotting. You can interactively have these maps. So the interesting thing here is that I can change the dashboard if I put more. Okay, and if I reload that, I can put always rerun. So, and the map is gonna change it accordingly. So same thing with the data, with the plottings. For example, if I change here and of course I need to change this one as well. So the map will be reloaded without the size property. So yeah, this was just a brief overview of the components. I tried not to spend too much time as well on this visualization because these videos start to become too long. And yeah, so any questions, just let me know. Thank you.